Here's the definition of an isomorphic graph. All of these graphs are isomorphic. That means they're of the same form, but they look different. What about these two graphs? Are they isomorphic? The first thing we need to do is to count the number of vertices in each graph. Do they have the same number of vertices? The next thing to do is to check the degree or the valency of each vertex. So we can see that vertex A has degree 3, B has degree 2, C has degree 3, D has degree 3, and E has degree 3. For the other graph, so we can see that both graphs have the same number of vertices, and they both have 4 vertices of degree 3 and 1 vertex of degree 2. But is this enough to say that they are isomorphic? Have a look at these two graphs. They both have 6 vertices. They both have 3 vertices of degree 1, 2 vertices of degree 2, and 1 vertex of degree 3. But are they isomorphic? The key lies in looking at what is connected to what. So for example, let's identify the vertices of degree 2. Now you can see in the first graph, the one on the left, that they are not connected, but in the graph on the right, they are. So these two graphs are not isomorphic. To determine whether a graph is isomorphic or not, one technique we can use is something called an adjacency matrix. A matrix is just an array of information, and the information contained in this 5 by 5 matrix is a graph. It just shows how the vertices are connected to other vertices and the number of edges between them. So this graph has 5 vertices, A, B, C, D, E. Vertex A is connected to B, D, and E. So we can draw edges as follows. Vertex B is also connected to C, so we can draw an edge there. Vertex C also connected to D and E as well as B. Vertex D is also connected to E, so we can draw an edge there. Vertex E we've already taken care of. We have all of the connections in the final column done already. So that's just the adjacency matrix for the graph that we've already done. So now we just need to work out the adjacency matrix for the other graph. Start by having a look at the vertex which has the same degree. So vertices B and R both have degree 2. All of the other vertices are degree 3. So we can see from the matrix that B is connected to A, C, A and C. And in the graph below, R is connected to Q and S. So we can say that A corresponds to Q and C corresponds to S. So let's have a look at A and Q. A is connected to B, D, and E. And we can see that Q is connected to R, P, and T. So now we can say that D corresponds to P and E corresponds to T, and we have our identical matrix, so the two graphs are isomorphic.